Hello students, we're going to learn how to build an atom. We're going to use the PhET sim and we are going to draw various atoms. But first, you're going to draw an atom from what you know about atoms. And this doesn't have to be perfect. It's kind of a reference for you to come back to see what you've learned during this lab. So before you start, before you go to the PhET site, draw yourself an atom. You can use the draw tools in Word if that's what you're working in, or you can use Notability. So once you've drawn your atom, you can go to Build an Atom in PhET, and you can look at it and figure out what building particles you have and how you're limited in where you can put those particles. Let's go check this out. So here's Build an Atom. Let's click on Atom here. And let's look at what we've got. We've got protons, we've got neutrons, and electrons. Here, we can open up and figure out what our net charge is. We can also click mass number here, and we can click stable and unstable to see if the nucleus is unstable. If we try to put protons here, they don't go in the outside loop. They don't go in the middle, and they just go on the inside. Let's try the same thing with neutrons. They don't go in any of the orbits. They just go into the nucleus. So protons and neutrons, we're limited. Putting it in the middle, that's the nucleus. And the electrons, if we try putting those in the shells, we can do that. So that's the first couple things. We can, of course, figure out what element we've created by looking over here at the periodic table. They're just using the abbreviations, like He is helium. If you don't know what element is, you can look it up in a periodic table online, or you can just Google it, and it'll tell you this element He is helium. You can notice that the mass number, or the atomic mass, is 1, 2, 3, 4. So there are 4 particles in the nucleus, and the mass number is 4. So how are we limited where we can put the particles? Only the protons and neutrons can go in the nucleus, and only the electrons can be around the outside. Which particle or particles affects the element name? Well, I'll give you a hint here. Watch the periodic table here. When I add protons and when I add neutrons or electrons, we'll add another proton here and see what happens. So that'll give you a clue for number 3. Based on model 2, which is in the PhET, what do all the oxygen atoms have in common? Well, let's get to oxygen. Let's make an oxygen. There's oxygen. We can keep adding neutrons, and it's still oxygen. We can add some electrons, and it's still oxygen. Oops. We can add some electrons until it's a neutral atom. It's still oxygen, but if we take out a proton, it turns into nitrogen. Put that proton back, it turns into oxygen. So it looks like these protons are pretty important in determining what your identity is as an element. Which particle or particles are responsible for the mass of the atom you build? Let's go experiment a little bit here. Here's the mass number of 16. If we take out a neutron, it drops to 15. If we take out a proton, it becomes a different element, and the mass number drops to 14. If we take out another proton, it drops another, changes to another element, and the mass number also goes down by 1. If we take out a neutron, it goes down. If we take out another neutron, it goes down. Take out another neutron, it goes down. If we take out a carbon, or excuse me, we take out a proton, it goes down. If we reset, we can see what affects the mass number here. If we put in a neutron, the mass number goes up to 1. If we put in a proton, we're now up to 2. We put in another neutron, we go up to 3. Put in another proton, we go up to 4. So hopefully you have an idea at this point of what is causing the mass number, is what affecting the mass number. How many different uncharged, neutral, stable hydrogen atoms can you build? In the space below, briefly describe the similarities and differences in their composition. Well, we did this for helium in class. You need to do it for hydrogen. So hydrogen is only going to have 1 proton because it is the very first thing on the periodic table. We can build, here's a perfectly good hydrogen. Here's another perfectly good isotope of hydrogen. And remember, isotopes, you're only dealing with adding or subtracting neutrons. So here is another isotope of hydrogen, but it's not stable. So it's asking how many stable isotopes of hydrogen. So it looks like we've got 1 there and 1 there. So next, we have to use the simulation in the symbol mode. Look at the bottom of the screen next to the house. I'll show you that in a minute. To complete the first row of the table below, and then build stable charged atoms of at least 3 other elements. So here we are in the PhET. Here's the little house I was talking about. Here's atom, where we were in the beginning. Let's go to symbol mode. And let's experiment in symbol mode. Let's build a helium. So let's put in 2 protons because helium has an atomic mass number of 2. And let's put in a couple protons. And let's put in a couple electrons. We'll have to look at exactly what the charge on is helium. So we can see this is the number of protons right here. This number in the bottom left corner. In the top left corner, we have the atomic mass, or the protons plus the neutrons. So protons and neutrons, everything in the nucleus is up here. And this is the charge. So our first mission here is to do H plus. So 1 proton, and that's it. So I've done the first one for you. We made a hydrogen atom. We'll clear this here. If we make a hydrogen atom, it's really simple. We just put in 1 proton, and if we want a positive ion, we leave the electrons off. And so this has the symbol 1, 1 plus 1, which is exactly what's on our lab sheet here. 1, 1 plus 1. It has 1 proton, 0 neutrons. No other element will probably have 0 neutrons. 0 electrons, a mass number of 1 because there's only 1 proton, no neutrons, a net charge of +1. There's a proton without an electron to balance it, and it is stable because it says it's stable. We can use this little checkbox here, which we will turn on to tell if the atom is stable or not. Let's make some helium. So if we add another proton, we're going to have some helium. We want to make sure that we create a stable. If I take off these neutrons, it becomes unstable. So let's create a stable atom of helium. Let's put in 1 electron. It is supposed to be a charged atom. So now we have helium that's 4, 2, and +1. So let's go back to our chart here and type in helium. We have 4 at the top, so I'm going to superscript that in Word. And we have 2 at the bottom, and I can't, oh. I don't want that superscripted, I want it subscripted. That's really not the correct way to do it. It should be 4 right on top of the 2, but we'll work with it that way. And then we'll superscript our +1. So it looks like the symbol here. So we want 4 on top of the 2 and the +1. So we want a stable charged atom of at least 3 other elements. So here's one other element. We know we have 2 protons because we can see that right here in the symbol. The lower left-hand corner is protons. We know we have 2 neutrons. We can either look on the sim and we can see that we have 2 neutrons. Or the better way to do it is take the atomic mass, which is neutrons plus protons, subtract the proton number, and that gives us the net number of neutrons. So 4 minus 2 equals 2 neutrons. Number of electrons, we just put in 1. We know that because we have 2 protons, we still have +1 charge. So we know that we only have an electron. If you're missing that idea, we can go over here to atoms, and we can build this same atom. We can build helium again. And we can see here that we have a positive proton here without a negative electron to cancel it out. So our total charge is +1 here. And the atom view has a little bit better view of net charge. So you might want to switch over to atom view and build your atom here in atom view as well as symbol view to get an idea of how that charge happens. The mass number we know is 4. That's right here in our symbol, upper left-hand corner. We know the net charge is +1. And it is stable because the box says it's stable. So it's stable. We know it's +1. We know it has 2 protons. We know it has 2 neutrons from looking here, or we can take the atomic number, or excuse me, the atomic mass, take the mass number, subtract the number of protons, and that'll give us the number of neutrons. So you guys can do a couple more. You can do lithium. That should be pretty simple. That's right here on the periodic table. You can do beryllium. That's just got 4 protons. That's pretty straightforward. You could also do boron or carbon. Those are pretty straightforward atoms. I would stick to this second row right here. So as you finish up your table, you're going to want to go down your sheet here and think about which particle or particles affect the net charge of the atom you build. Justify your answer with your data from your table above. So let's go and just take a look at what makes charge. We've gone back to atom on the bottom. It's right next to the house. And so you can see the net charge here. So if you're a little confused, go back down to the black strip at the bottom and click on atom. So here's that bottom menu. Click on atom so you can see the net charge here. You might have to open this box. It'll be a green plus sign, and just click that and the net charge will come up. And let's just kind of play around with net charge here and see what happens. So the net charge shows us the number of protons and the number of electrons. So if I put another electron here, you can see that the negative electron cancels out the positive proton and the net charge goes to 0. If I add more electrons, which would not really happen in helium, I have 2 extra electrons and I have 2 negative charges that don't have a positive charge to balance them, so my total charge is -2. You can see up here that there's 2 more electrons than protons, so it's an unbalanced atom and it has a charge of -2. If I add another proton and I make it lithium, it's unstable, so I need to add another neutron. That doesn't affect the charge, but adding another proton balanced one of those negative charges. Anything inside this box is balanced. So there's a positive and a negative, and that makes a pair. +1 and -1 make 0. +1 and -1 make 0 for the second pair here, and +1 and -1 make 0 for the third. There's 1 extra electron that doesn't have a proton partner, so the total net charge is -1. The other way to think about it is +3 plus -4 equals -1. Let's do a different one here. We have +4 plus -4 equals 0. If we add another electron here, as I have, we have a negative ion, and the reason it's negative is now we have positive floor plus -5, because we have 5 electrons, all which have a charge of -1, so this is -5. We have an extra electron that doesn't have a proton partner, so we have -1. +4 plus -5 is -1. If we put 1 more electron on there, we have another electron that doesn't have a proton partner, so we have a net charge of -2. Or another way to think of it is +4 for all the protons here, 4 protons, plus -6 for the -6 electrons equals -2. If we add another proton and make it a new element, if we make it boron, it's +5 plus -6 equals -1. So you can see that protons and electrons have the charge. Neutrons, by definition, they're neutral. They don't have a charge. So they don't enter into calculating whether it's a negative or positive atom. A negative or a positive atom is an ion. If we shift this charge to positive, it becomes a positive ion, and you can see that positive charge matches the protons. If we shift the charge to being negative, it's a negative ion. This is really, really important in understanding chemistry. So if you can wrap your head around the fact that protons plus electrons, remember electrons are always negative, so it's really protons minus electrons gives you the charge. I'll let you play around with that a little bit more and kind of figure it out and give an example. So we figured out which particles affect the charge, which make which particles make it a positive or negative ion. That means a charged atom. In the space below, we want a general equation. So how do you add protons and electrons to get the charge on any atom? You can describe that in some kind of equation there, make a number sentence, and then give an example to show how your number sentence is accurate. So, considering what we've learned in questions 2 through 9, would you want to change the drawing of your model at the very beginning of this lab? Why or why not? Briefly explain why you would or would not want to change your model that you did in question at the very beginning of the lab in question 1. In a single grammatically correct sentence, describe what you believe is the most important point to remember from questions 1 through 10. You might want to say something about ions. You might want to say something about how to calculate the atomic mass, or what particle is the identity or the Jersey number of the atom. What single number identifies what element you're dealing with. So then it's time to play the game. This is kind of fun. You go to the bottom screen here and you select game. It's the one that's the third one over from the little black house on the very bottom of the web page. There are 4 levels, 1, 2, 3, 4. You need to play them all. And you need to kind of reflect on your play. A is how did you use your info on protons, neutrons, and electrons to pick an element? And how did you decide if the atom was neutral or not? Level 2 is calculating mass number, and how did you figure out how to do that? And how did you figure out how to calculate the total charge? Level 3, you have to fill out part of the box on the periodic table of an element. They give you representations of an atom. Which one do you think is the easiest for you to figure out? And that's a personal answer, but do explain your answer. And then level 4 is supposed to be the most difficult because they're showing you a lot of representations of the atom. Which one was the most difficult for you to interpret? And then when you're done, draw your name on your results and post your results like this. If you want an extra challenge, you can turn on the timer and see if you can improve your skills. So we'll play the game really briefly. I won't show you all of the answers. I'll just give you an idea of how to play the game. So remember to switch into game mode. You just go to the bottom and you click on game. So here's how to switch on game. We can choose level 1 here. I'm supposed to pick an element, and I know there are 8 protons. Protons, I know, are like your Jersey number or your phone number. It's what identifies you as a particular element. So what element has 8 protons? Well, let's count. Hydrogen has 1, helium has 2, lithium is 3, beryllium's 4, boron's 5, carbon's 6, nitrogen 7, oxygen is 8. So let's click on oxygen. All right, it has 8 protons and 10 electrons. 8 minus 10, because electrons are negatively charged, means it has a charge of -2. So it's an ion, it's not neutral. If its charge is 0, it's neutral. All right, awesome, we got that one correct. I'll show you an example of how to play level 2 here. What is the mass number? Well, I know that protons plus neutrons is the mass number, so 10 plus 11 equals 21. So if I keep bumping up the mass number here, all right. If I was going to keep playing the game, which is what you should do, is click next. I'm going to click start over so I can go to the next level. Here's an example of level 3. Not all the questions will look exactly like this. You'll have to make some different decisions. But right now we need to know the mass number. So I can just count the protons plus neutrons here. 1, 2, 3, 4. So I know the atomic mass number, which is up here in the corner here, is 4. All right, we got it. Okay, let's play level 4. So this time we have helium, and we have to build helium. So we know we have 2 protons, and I know that from looking at the lower left-hand corner, that's the atomic number, that's the number of protons. I know the number of neutrons because the atomic mass here is the number of protons plus the number of neutrons. Or I can take the atomic mass minus the number of protons, and that gives me the number of neutrons. So I can add 1 neutron here. So we have 2 protons. We have 1 neutron. That makes an atomic mass of 3 here. And now we need to get a neutral atom. So if we have 2 protons, to balance those 2 positive charges, we need 2 negative charges. Awesome. We have a molecular weight of 3, we have an atomic number of 2, and we have a neutral atom. So now you know how to play all the different levels of games. You can play, and when you're all done, you can put up your score. Take a screenshot and put it at the end of the lab. If you want, you can turn the timer on, and that kind of makes it a little bit fun. You can see how fast you can do it. When you take your screenshot, put your name on your screenshot. Thanks so much. This is Dr. B signing off on Build an Atom.